Hello students, today we discuss eigenvalue and eigenvector. So first we look what is eigenvector. Eigenvector is a vector that is scaled by a linear transformation but not move. It means suppose we have some a transformation, suppose a matrix A which is of n cross n order. So A is a transformation and we apply A over a vector x. X is a vector. Suppose this is a vector x, and after applying a transformation A over x we get some another vector y. If y it is some another direction, then it's simply another vector. But if y is particularly in the same direction of x, then we say this is what if suppose y is exactly in the same direction of x, then we say x is what eigenvector, and y is some either or might be traced of x, or it might be shrink of x. So it y is actually some factor of x. That factor is a scaling factor, and that factor is known as eigenvalue. How many times of x is y? So if y is in the same direction of x, then it is x is eigenvector. It might be stressed of x, or it might be shrink over x, or if it is some another direction, it is some another vector. So eigenvector is a vector that is scaled by a linear transformation or a matrix transformation. Matrix transformation is also a linear transformation but not moved. It may be stressed, shrink in its own direction, in the same direction. The characteristic equation, now look another definition, which is characteristic equation. So what is characteristic equation? Let A be a square matrix, n cross n, it might be order of n cross n, and I be a unit matrix, identity matrix of same order, and lambda is any scalar quantity. Then the matrix A minus lambda I, the order of this matrix also same as the order of A, is known as characteristic matrix, and the determinant of this characteristic matrix, which is given by this, is a polynomial in lambda of degree n, and that polynomial is known as characteristic polynomial or characteristic equation. So this characteristic polynomial construct the characteristic equation, which is given by this polynomial expression is equals to 0. That is, determinant of A minus lambda I is equals to 0 is the characteristic equation for given matrix A. It's very important to find characteristic equation of given matrix for calculating eigenvalues and eigenvector. So with the help of characteristic equation, we can also define eigenvalues. So the roots of characteristic equations of a square matrix is known as eigenvalue of that matrix. So the roots of lambda, this is a characteristic polynomial, and from this we can find characteristic equation. Roots of this equation is known as eigenvalue of given matrix A. And eigenvector x corresponding to eigenvalue lambda means roots of this equation, which is lambda, is the non-trivial solution of this is a system of equation where coefficient matrix is what? Characteristic matrix. Coefficient matrix is characteristic matrix, and x is what? A vector non-trivial solution of the system of equation. So all those set of the solution, non-trivial solution, are what? Eigenvectors of corresponding to lambda, a particular eigenvalue. So about each eigenvalue we find some eigenvector. Actually these are infinite there are infinite number of eigenvectors corresponding to a particular eigenvalue, but out of these infinite only few are independent, rest of all are dependent eigenvectors. So we have a problem here, how to find eigenvalue and eigenvector. So here we have a matrix, a 3 cross 3 matrix, it's named by A. First we have to find its characteristic equation. After that we have to find its eigenvalue, and about each eigenvalue we will find eigenvector. So to find its characteristic equation is what? Determinant of A minus lambda I is equals to 0. It means we are to subtract lambda from diagonal element. So we get 8 minus lambda, 7 minus lambda, 3 minus lambda in place of diagonal elements. Rest of elements are as it is. And this determinant is equals to 0. This is known as characteristic equation. Now we will simplify this equation. So we get lambda cube minus 18 lambda square plus 45 lambda is equals to 0. Or we can factorize it. Its factors are lambda minus 3 and lambda minus 15 is equals to 0. So from here we get the values of lambda, which are 0, 3 and 5. These are eigenvalues, and this equation is known as characteristic equation. Lambda cube minus 18 lambda square plus 45 lambda is equals to 0 is characteristic equation, and these are characteristic roots or eigenvalues. Now about each eigenvalues we will find eigenvector. So first we will find the eigenvector about the lambda is equals to 0 eigenvalue. So suppose x1, capital X1 is an eigenvector corresponding to lambda is equals to 0, which is given by A minus 0i. This is coefficient matrix of the system of equation. X is the non-trivial solution of this system of equation, and A minus 0i is what? Characteristic matrix about the characteristic root lambda is equals to 0. So here we put the value lambda is equals to 0, we get A minus 0i is equals to A. Now we will solve this. To solve it, we first convert this coefficient matrix into echelon form. So first reduce A into echelon form using elementary transformation. So first we interchange first and third row. So we get third row in place of first row and first row in place of third row, second as it is. Now we will convert this minus 6 and 8 into 0 with the help of first row, and using the elementary transformation, R2 replaced with R2 plus 3R1 and R3 replaced with R3 minus 4R1. Hence we get this matrix. Now we will convert this 10 into 0 using elementary transformation and with the help of second row. So it becomes, third row becomes 0. Now divide second row with minus 5, hence it becomes 2 minus 4, 3, 0, 1, minus 1 and 0, 0, 0. So from this reduced echelon form we can write this system of equation in simplified form, which is given by 2x1 minus 4x2 plus 3x3 is equals to 0 and x2 minus x3 is equals to 0. From here we obtained x2 is equals to x3. There are 3 number of variable and 2 number of equations are 2, so one independent variable, say let's suppose x3 is equals to k, where k is some non-zero arbitrary constant. So if x3 is k, so x2 is also becomes k. Now putting the value of x2 and x3 in this equation, we obtain 2x1 is equals to x2, implies we get x1 is equals to half k. So capital X1, which is the root of, which is an eigenvector corresponding to eigenvalue lambda is equals to 0, is constructed by x1, x2, x3. Here x1 is half k, x2 is k and x3 is k. So if we choose k as 1, so eigenvector becomes half, 1 and 1. It's not necessary that we choose k as 1 only. We might take it as 2. If we take k is equals to 2, it becomes 1, 2 and 2. So this is an eigenvector corresponding to lambda is equals to 0, and it's only independent eigenvector for this system of equation and rest of all the eigenvectors which satisfy this set of equation are dependent over this. Now we will find the eigenvector for another eigenvalues which is lambda is equals to 3. So let's suppose x2 is an eigenvector and which is given by a minus 3i x2 is equals to 0. This is characteristic matrix. So here we replace diagonal element with diagonal element minus 3. So the matrix becomes 5 minus 6 2, 6 minus 6 4 and minus 4, and third row become 2 minus 4 0. And to solve this system of equation, first we convert this coefficient matrix into echelon form using elementary transformation. So first we choose R3 replaced with half R3. Now after applying this elementary transformation, we will interchange first row and third row. So first row becomes third row and third row become first row, second row remains as it is. Now we will convert this first element of second row and first element of third row into 0. For that we use first row, and using the elementary transformation R3 replaced with R3 minus 5R1 and R2 replaced with R2 plus 6R1, we get this matrix. Now we will convert this 4 into 0 with the help of second row. We use elementary transformation R3 replaced with R3 plus 2R2, we get this one. And now in this matrix we will use elementary transformation R2 replaced with minus 1 by 4 R2, hence we get the reduced echelon form, which is 1 minus 2 0, 0 2 1 and 0 0 0. It leads us for the system of equation x1 minus 2x2 is equals to 0, and second is 2x1 plus 2x2 plus x3 is equals to 0. From here we obtained 2x2 is equals to minus x3 and x1 is equals to 2x2, implies x1 is equals to minus x3. Now again we choose x3 is equals to k, so we get x1 is equals to minus k and x2 is equals to minus half k. And if we take k is equals to 1, this eigenvector become minus 1, minus half and 1. Or in place of 1, if we choose minus 1, it becomes 1, half and minus 1. Or if we choose 2, it becomes minus 2, 1, minus 2, minus 1 and 2. So this x2 is an eigenvector about eigenvalue lambda is equals to 3. Similarly, we will obtain the eigenvector for eigenvalue lambda is equals to 15. Let's suppose x3 is an eigenvector is given by the system of equation a minus 15i x3 is equals to 0, and similarly we will convert this coefficient matrix into echelon form using elementary transformation. Hence we reduced this coefficient matrix into the echelon form, which is 1 minus 2 minus 6 and 0 1 2 and 0 0 0. From here we get system of equation which is x1 minus 2x2 minus 6x3 is equals to 0 and x2 plus 2x3 is equals to 0. So again we choose x3 is equals to k, we get x3 is equals to 2 minus 2 and 1 when we take k is equals to 1. So this x3 is an eigenvector corresponding to the eigenvalue lambda is equals to 15. So in this way we find